So this is evaluating trigonometric functions part 2, and this lesson will make more sense because we have reviewed the unit circle, especially quadrants 2, 3, and 4, and exactly how we can determine different ratios depending on different angles in those three quadrants. So here I have some problems. Again, it's all about evaluating and simplifying functions. So to start off, we have something like cosine of 5 pi over 6 plus sine of 4 pi over 3 plus tangent of pi. So if we look at this really, we always should think about the reference angle really. So here we know the reference angle is pi over 6, here being pi over 3, and obviously this is just pi. So those are the reference angles. Now if you remember the rule I had mentioned earlier, 5 pi over 6 really means the fact that the numerical value in the numerator is 1 less than the denominator, indicates that this is a angle in the second quadrant really. And so when you take cosine of this, again, you always want to think of taking the cosine of pi over 6. Cosine of pi over 6, if you remember, is root 3 over 2. However, this is in the second quadrant, and the rule is all students take calculus. So in quadrant 2, only sine values will be positive. Cosine will therefore be negative. So we know cosine of pi over 6 is root 3 over 2. Therefore, cosine of 5 pi over 6, this angle being in quadrant 2, should be negative root 3 over 2. Now, we're adding this to sine of 4 pi over 3. Now, if you recall, again, if the numerical value in the numerator is 1 more than the denominator, then it's really in quadrant 3. And with quadrant 3, it's all students take, so tangent is positive in quadrant 3. Sine, cosine, everything else is really negative here. So if we look at this, we know that sine of pi over 3 is root 3 over 2, but this is in the third quadrant, therefore this one is plus, similarly negative root 3 over 2. Now looking at tangent of pi, so again we're not using our calculators here, but if we don't exactly, or if you haven't memorized the values of tangent so far, again what you can do is you can write this as sine pi divided by cosine pi. And so what this now means is that so obviously this is sine pi over cosine pi. And if you think, again, always draw a pictorial if you get confused here. But really on this side, so if I have a unit circle like this, something like this, we know that pi is here. And really if it's a unit circle, this point has to be negative 1, 0. Right? Therefore, we're really saying, and we know that any point on the unit circle is cosine theta comma sine theta. So really, sine theta, the y value, is 0, right? And cosine of that angle, or in this case, cosine of pi, is negative 1. Therefore, really, tangent of pi is 0. So this value over here, or tangent of pi, this is just 0. So we're really just looking at these two. And the fact that there are two of them, we can write this as, this is equally negative 2 root 3 divided by 2. And so simplifying this further, we obviously get negative root 3 as our answer. So negative root 3 is the simplification of this. So now we'll just give another problem here. Again, similar concept. Again, if you know your ratios really well in those three quadrants, this should not be hard. So now in this problem here, what I have done is I've taken really the other three trigonometric functions that we really haven't gone into too much depth here. They're the reciprocals of the three primary ones of sine, cosine, and tangent. So the problem is secant of pi over 4 plus cosecant of 5 pi over 6. And the thing with this is that really, you know that the secant is really a reciprocal of cosine, cosine of theta, and then the cosecant is a reciprocal of sine of theta. So when you're talking about the all students take calculus, when you say students, really means that in quadrant 2 sine is positive. It also means that in quadrant 2 cosecant of a particular angle, that's also positive because it's just a reciprocal of sine. So if sine is positive in quadrant 2, then cosecant of that angle will also be positive just because it's only the reciprocal of sine of that angle. So here when we're looking at this, we always sort of think this as what's cosine of pi over 4? Well, first of all, pi over 4 is in quadrant 1. So if we take cosine of pi over 4, that's just root 2 over 2, if you remember from the unit circle. Secant of pi over 4 will be its reciprocal. Therefore, this value here would be 2 over root 2. Now looking at this one, so here we are saying 5 pi over 6. Again, if you can recall, 5 pi over 6 is in quadrant 2. And when we take sine of 5 pi over 6, so that gives us a value of 1/2. And again, because sine of pi over 6 is 1/2, because it's a reference angle, sine of 5 pi over 6 is just in quadrant 2, which is positive because it's all students. That remains 1/2. However, because it's cosecant of that angle, we have to take its reciprocal. Reciprocal of 1/2 is 2. So we're adding 2 here. Now we can find the common denominator. So again, multiplying the denominator by root 2, we have to do the same on the numerator. So we get 2 plus 2 root 2 all over root 2. However, we have a radical in the denominator, and to further simplify this, you probably want to multiply this by root 2 over root 2. And so you get 2 root 2 plus, again, multiplying root 2 by root 2, you get 2. So 2 times 2 is 4. And then root 2 times root 2 is again 2. So our final answer is 2 times root 2 plus 4, all divided by 2. So yeah, this is basically evaluating trigonometric functions. And again, if you understand the ratios in the 4 quadrants, this one should be pretty easy to understand. So thanks for watching.